Our learning outcomes are to draw an electrolytic cell. Second, to describe the operation of an electrolytic cell. Okay. And to explain the influence of the following factors of selective discharge of the species at the electrode. The first is standard reduction potential, or SRP, of the species, then the concentration of the species, and the nature of the electrodes, active or inert electrode. And the last is to state the Faraday's law of the electrolysis. Definitions of electrolysis. Electrolysis. Electrolysis is a chemical process that uses electricity for a non-spontaneous redox reaction to occur. Such reactions take place in electrolytic cells. Next, we move to the electrolytic cell. An electrolytic cell is made up of two electrodes immersed in an electrolyte. A direct current is passed through the electrolyte from an external source. Example of the electrolyte is a molten salt and an aqueous ionic solution, which are commonly used as an electrolyte. Let us look at the terms in an electrochemistry. The first one is the electrode. Electrode is as the circuit connectors, the sites for the precipitation of insoluble products. The example of electrode are platinum and graphite, which is an inert electrode. The second one is electrolytes. Electrolytes are the liquid that conducts electricity due to the presence of positive and negative ions. Electrolyte must be in molten state or an aqueous solution so that the ions can move freely. The examples of the electrolyte are potassium chloride, hydrochloric acid, and acetic acid. As we know the electrolysis using an electricity, so the battery is used as a source of direct current that forces electron from anode towards cathode. During electrolysis, an ion moves to anode, give up the electron, and become oxidized to atoms. The reactions when the electron moves to anode can be written as below. So Y ion considered as an aqueous will return to the atom Y when the electron become oxidized to atoms. At the same time, cation move to cathode, gain electron, and become reduced to atoms. And we can write the equation at cathode as X ion aqueous turns to X atom when it is going to be reduced. Thus, oxidation reaction takes place at the anode while the reduction reaction takes place at the cathode. The overall cell reaction can be written as Y ion and X ion turns to Y atom and X atom. Let us look at the anode and cathode criteria. Anode is the positive electrode, which is the electrode connected to the positive terminal of the battery. And also the oxidation reaction takes place. The cathode is the negative electrode, where the electrode is connected to the negative terminal of the battery. And the reduction reaction takes place. In electrolysis, the electrons flow from anode to cathode. The comparison between an electrochemical cell and electrolytic cell can be seen with these two diagrams. In electrolytic cell, we use the electricity, while the electrochemical cell generated the electricity. In the diagram, we can see that the positive terminal of the electrolytic cell is the anode, while the positive in the electrochemical cell is called the cathode. Besides, we can see the cathode in the electrolytic cell is the negative terminal, and the negative terminal in the electrochemical cell is an anode. But we can see from the both diagram, the flow of electron is from anode to cathode. The difference between galvanic cell and electrolytic cell can be summarized as below. First, electrolytic cell. In the electrolytic cell, the cathode is the terminal negative, while in the galvanic cell, cathode is the positive terminal. Anode in the electrolytic cell is the positive terminal, while anode in the galvanic cell is a negative terminal. Next, in electrolytic cell, no need to use salt bridge, while in galvanic cell, we need to use salt bridge. Electrolytic cell need to use batteries, but in galvanic cell, no need to use batteries. Electrolytic cell only use one electrolyte, while in galvanic cell, at least 2 electrolytes must be used. And last, electrolytic cell is a non-spontaneous redox reaction which requires energy, while the galvanic cell is a spontaneous redox reaction which releases energy. Oxidation occurs at anode, while the reduction occurs at cathode. Second, anions move towards anode, while cations move towards cathode. And the third one, electrons flow from anode to cathode, in an external circuit. Next, let's check the factors affecting the selective discharge of the species at the electrode. The first factor is the standard reduction or the electrode potential of the species. Second, the concentration of the species. And the third one is nature of electrodes. The first factor is about the standard reduction or the electrode potential of the electrode. Let us check at the anode. Which anode undergoes oxidation, so the electrode potential has more negative value will oxidize at anode. The more negative means has the lower value. In cathode, as we know it is undergo the reduction, the electrode potential has more positive. It means higher value will reduce at the cathode. The example of oxo anions such as sulfate ion, carbonate ion, nitrate ion, and phosphate ion, and also the ion fluoride ion, but the fluoride ion not oxidized. It is because the central atom is already at its highest oxidation state. Look at the example. The first one, which species will be reduced? Either sodium ion or water. To answer this question, you must check the reduce, meaning that undergoes reduction process. Okay, the reduction process in between sodium ion and water can be checked in the SRP table, and we can write the equation for the sodium ion as shown, and we just take out the E0 value for the sodium ion is negative 2.71 and water is negative 0.83. Compare these two values and we check E0 more positive. So from the answer, we can see water is the species could be selected to be reduced at cathode. Second example, which species will be oxidized, meaning that undergoes oxidation. Okay, in between chloride ion and the water who can be oxidized. Then we check the SRP table to take out the E naught value. And we can see the chloride ion has more positive comparing to the water. So the answer is water will be oxidized because the E naught of water is more negative. Let us check the third example. It is an anomalous case. Which species will be oxidized? Sulfate or water? To answer this question, we must check the SRP table for both ions, for the sulfate and also the water. And we take out the E naught or the standard reduction potential value. After that, we compare these two E naught and we can see to oxidize or undergoes oxidation. So it must be the E naught has more negative value. So the more negative value comparing for these two ion is sulfate ion. So it is supposed to answer this question as sulfate. But the answer is water. Why is it so? So the answer should be as the also an ion because of the sulfate is an also an ion which cannot be oxidized. Because the central atom S is already at its highest oxidation state. The second factor is a concentration of the species. The concentrated species will be oxidized at anode. Example, which species will be oxidized in concentrated electrolyte, chloride or water? To answer this question, first of all we have to take out the SRP equation from the table and take out the number of E naught values. From the values, need to compare between these two species and we will check that normally the more negative could be selected to be oxidized at anode. But in this case, if the concentration to the chloride ion is more than the water, so that the answer is not water, but the answer is chloride ion. In aqueous solution, chloride ion will be selected for oxidation because chloride ion has high concentration and the rate of oxidation of chloride ion is faster than the rate of oxidation of water molecules. The third factor is the nature of electrodes. In electrodes, example graphite and platinum are normally used in electrolysis. It is because they do not involve in the reaction. Look at the diagram below. When the graphite is used as the electrodes, so the positive and the negative terminal has been labeled as the anode and cathode. What will happen in this reaction when we use copper sulfate as an electrolyte? In the electrolyte, copper sulfate has two ions, which is copper ion, the positive ion, and the sulfate ion as the negative ion. So the copper ion will move to the cathode or the negative terminal, while the sulfate ion will move to the positive terminal, unless we also have the water. Who will be selective? Copper ion at the cathode or the sulfate ion at the anode, or water? So in here we can see the anode as the oxidation and the cathode undergoes the reduction. So the species involved in the reactions at the anode is sulfate and water. At the cathode also has copper and water. At anode, the oxidation occurs, so the water will be selected to release oxygen, while at the cathode, the copper ion will be selected to become an atom. So the overall equation can be written as 2 copper ion in aqueous plus water to give copper solid and the oxygen. An active electrode such as copper will dissolve if the electrolyte contains the ions of the same metal. In the diagram below, as the copper is used as an electrode, we can label the anode and cathode at the positive terminal and also the negative terminals. As the electrolyte used is also has the same metal with copper, which is the copper sulfate, what will happen at the anode and the cathode? At anode undergoes oxidations, the copper electrode ionized to become copper ion. At the cathode, which undergoes reductions, all the copper ion will selected to discharge at the cathode to be copper solid. The equation at the anode and cathode can be written as shown. The overall equation can be written as copper ion aqueous plus the copper solid to become copper solid and copper 2 plus aqueous.